The next 3 lessons are going to be focused on something called systems of equations. Systems of linear equations just mean 2 or more linear equations, and these can be solved by finding the point where the graphs of the different lines meet. There are 3 different ways to find those solutions. The one we're going to start with today is graphing, like this over here. So, start with your vocabulary, please. And notice that you do not have all the vocabulary that's in the lesson for 6.1. System of linear equations, 2 or more linear equations. The solution of a system, any ordered pair that is a solution for all of the equations of the system. So notice the solution for a system is going to be an ordered pair. For example, given the lines x equals 0 and y equals 0, I picked easy ones, a solution for that system is 0, 0. Yes, in fact, x equals 0 and y equals 0 gives you the graph. There's your solution, the one place where those 2 lines meet. So, problem 1, I'm on page 360. What is the solution of the system? Use a graph. Well, here's your system. It is made up of these 2 equations. First step, if you're going to use a graph, is going to be to graph those 2 equations. Notice how they use 2 different colors here. That helps make things nice and clear. Not a bad idea to throw an extra colored pencil in your bag, so you can do this at school too. Y equals x plus 2. The slope is 1. The y-intercept is 2. They put it here in red. They graphed it here in red. Y equals 3x minus 2. The slope is 3. The y-intercept is negative 2. And they graphed it here. These 2 lines cross at this one point. That one point, 2, 4, is the solution to this system of equations. Then, because this is an imperfect way to find your solution, when you solve by graphing, you should check your work. How do you check your work? Well, you plug 2, 4 into this equation and into this equation, and it works out both times. So that is in fact the correct solution. Try this again, including checking your answer for got it number 1 on the top of page 361. So here are the 2 equations that they gave you. Those 2 make up the system that we're working with. And here is my graph of these 2 equations. I used different colors, but I also wrote the equation very close to its line so that you could tell which is which. And somewhere all muddled up down here, you see the solution, and you see my little note. You'll notice I had to redraw my line a little more carefully. So it looks like the solution is at negative 2, 0. But as you can tell, I'm kind of guessing, so you're going to have to check it. Fortunately, lucky for me, that worked out. So problem 2 involves baby alligators. You don't get to work with that just any day. You've got 2 alligators. Scientists are studying their growth, their weight and growth rate. So at what point did these 2 alligators weigh the same amount? Here are your facts. Alligator 1 started at 4 pounds and grew 1.5 pounds per month. Alligator 2 started at 6 pounds and grew 1 pound per month. So to break it down, you need to know the initial weight is, the alligator weight is, which means equal sign, equal to the initial weight plus, so we're adding something here, the growth rate times time. And then they lay out the variables. Let W be the alligator weight, let t equal the time in months. And then, oh, I love how these colored boxes match, so it's easy for you to figure out what they did. Weight equals initial weight plus the growth rate times the time. Let me zoom in so you can see that better. Oh, much better. The first alligator, remember, started at 4 pounds and grew 1.5 pounds a month. The second alligator started at 6 pounds and he grew, or she grew, 1 pound a month. So these are your equations. W equals 4 plus 1.5t. Graph them. They give you the slope, the y-intercept, slope, and I guess we should call it the w-intercept. And then they graphed them over here. Notice that this graph is appropriate to do only the first quadrant because you're only going to have positive alligator weight. And then you see where those two lines cross. At the 4th month, those two alligators weighed the same. At this point, you should try Got It number 2. Okay, page 361, Got It number 2. I'm going to tell you, I wrote this problem out a couple times for you because it just was ugly the first time I did it. Step 1, break it down. We have two variables. C is the total cost of your satellite radio service, and T is the time in months that you have had satellite radio service. The cost is the monthly fee times the number of months plus the activation fee. So for the first service, the cost is equal to $10 per month plus a $20 activation fee. The second service is $11 a month, but only a $15 activation fee. So, what's the solution to this system of equations? At what month have you spent the same amount of money for either service? So notice again, I graphed only in one quadrant because we're not talking negative money here. Notice also I used two different colors. Dark blue for the $10 a month service and this kind of pale purple for the $11 a month service. It shows the scale of my graph so that I wouldn't, be drawing hash marks up to 80, and drew the lines carefully. And you can see that they're crossing somewhere up here. This is why we have to check our answers. So I figured it looks like about 5 months. At 5 months, yeah, you can see they cross somewhere in here. And 5 months is right about the middle of that. So, does it work? Yes, it does. So 5 months is our answer. The last thing that I want you to know with lesson 6-1 is we've been dealing with systems of equations that have one solution, which means the two lines cross and there's one point that we think of as a solution. But there are a couple other possibilities. For example, if you have two equations that turn out to be the exact same line, this has infinitely many solutions because this line goes off in both directions to infinity. So you have infinitely many solutions when both equations plot or graph as the same line. Your third option is that you would have no solution, and that one only happens if your two lines are parallel, because that's the definition of parallel lines, right? They never meet. Otherwise, your two lines will always meet somewhere. So, You could have one solution, you could have infinitely many solutions, or you could have no solution. And here's what you're waiting for. You've got a bunch of graphs to draw. I'm hoping that you get to number 41, but you may not in one class period. You should definitely be able to get these problems finished.